Friends, the International Space Station, ISS, orbits the Earth for space research and exploration. You've probably heard of this iconic space laboratory, but did you know there's a similar research lab located deep beneath the sea? Enter the Aquarius Reef Base, a facility nestled among coral reefs at a depth of 19 meters, about 8.7 kilometers off the coast of Florida. Established by NASA on July 23, 1986, this undersea base serves a unique purpose. Surprisingly, the conditions here mimic the hostile and extreme environments found in space. Since 2001, NASA has been utilizing this facility to train astronauts, preparing them for the unpredictable challenges of space. Inside this base, astronauts learn to survive in confined conditions, conduct experiments, and adapt to unexpected scenarios. These simulations replicate the challenges faced on the ISS or during future missions to Mars. To date, NASA has conducted 23 missions under its NEEMO program, NASA Extreme Environment Mission Operations. NEEMO is a training initiative where astronauts, engineers, and scientists hone their skills for living and working in space. But NASA's ambitions don't stop at astronaut training. The agency also uses the Aquarius Reef Base to explore alien oceans, such as those on Europa and Enceladus, aiming to unlock the secrets of life beyond Earth. How exactly does exploring Earth's oceans help us understand extraterrestrial ones? Stay tuned, and let's dive into this fascinating topic. Hello everyone, I'm Ravi, and welcome to a brand new episode. When we think of NASA, our minds often wander to the Moon, Mars, and the infinite expanse of the universe. But few know that NASA also applies its cutting-edge technology to the exploration of Earth's oceans. The story begins in 1978 when NASA launched its first oceanographic satellite, CSAT. Its mission was to collect critical data on ocean winds, surface temperatures, and wave patterns. This breakthrough didn't just advance climate science. It marked the beginning of NASA's deeper involvement in oceanography. Throughout the 1980s and 1990s, NASA launched advanced satellites, such as Topex/Poseidon in 1992, which accurately measured tides and sea level variations. By the early 2000s, NASA's focus on ocean research became more serious. Missions like JASON-1 and JASON-2 became milestones in understanding climate change and ocean behavior. In 2001, NASA took a bold step by converting the Aquarius Reef Base into an astronaut training facility, originally an undersea research lab. It became a testing ground where astronauts simulate spacewalks, test equipment, and rehearse for deep space missions. The individuals who work and train here are called aquanauts, and they usually stay in the base for 24 hours at a time. NASA has invested $500 million into this program, but the organization's efforts in ocean exploration go far beyond this single project. In 2014, NASA deployed a drone called Nereus to the Chromatic Trench near New Zealand. Designed to explore depths of 9,900 meters, the drone succumbed to the intense underwater pressure and imploded. Despite this setback, NASA continued developing lightweight, AI-driven submarines capable of exploring not only Earth's oceans, but also alien ones, such as Europa's. Europa, one of Jupiter's moons, has captivated scientists for decades. Beneath its icy surface lies a vast ocean, potentially 60 to 150 kilometers deep, holding twice the water volume of Earth's oceans. However, this ocean is hidden beneath a 15-kilometer thick ice layer, making exploration extremely challenging. In October 2024, NASA launched the Europa Clipper mission, an ambitious probe set to arrive near Europa by 2030. Its primary goal is to map Europa's ice crust, study its ocean, and assess the potential for life. But the Europa Clipper is just the beginning. NASA is also developing the Cryobot, a nuclear-powered robot designed to penetrate Europa's ice and explore its ocean. Communication challenges, such as radio signals being blocked by the ice, mean the Cryobot must use advanced autonomous systems to analyze data on-site. Europa isn't the only target. Saturn's moon Enceladus also harbors a subsurface ocean. NASA's Cassini spacecraft detected water plumes and organic molecules in 2005, hinting at possible life. Missions like the proposed Enceladus Orbilander aim to dive deeper into these mysteries. Similarly, NASA's Dragonfly mission, set to land on Saturn's moon Titan by 2034, will explore its methane lakes and underground oceans, providing insights into alternate life forms. Interestingly, we know more about Mars than about our own oceans. While 99% of Mars's surface has been mapped, only 23.4% of Earth's oceans have been explored in high resolution. The ocean floor remains largely uncharted, with regions as hostile and alien as Europa's. Take the Challenger Deep in the Mariana Trench, the deepest known point on Earth. Here, pressures are 1,100 times that at the surface, and temperatures vary from near freezing to 400 degrees Celsius near hydrothermal vents. Despite these extreme conditions, life thrives. Giant tube worms, amphipods, and bioluminescent squids create a thriving ecosystem without sunlight. These findings fuel hope that similar life forms might exist in alien oceans. Exploring alien oceans isn't just about finding extraterrestrial life. It also drives technological innovation. The autonomous submarines and AI-driven explorers designed for Europa could also map uncharted areas of Earth's oceans, such as polar ice caps and deep trenches. Projects like Seabed 2030, a global initiative to map the entire ocean floor by 2030, are vital. Meanwhile, NASA's Plankton Aerosol Cloud Ocean Ecosystem PACE mission, launched in February 2024, is analyzing phytoplankton and ocean health, providing critical data for climate studies. Exploring alien oceans helps answer one of humanity's biggest questions. Are we alone in the universe? If we find life in the oceans of Europa, Titan, or Enceladus, it will prove that life isn't exclusive to Earth. It's a universal phenomenon. This discovery could redefine our understanding of existence and inspire hope for humanity's future among the stars. Not only will these missions expand our knowledge of life, but they'll also provide insights into Earth's origins, climate, and ecosystems, while pushing the boundaries of technology. So, what do you think? Are these efforts worth the investment? Let me know in the comments. If you enjoyed this video, don't forget to like, share, and subscribe to the channel. Turn on the notification bell for more fascinating episodes. Until next time, goodbye.